One way to damage or destroy the magnetic properties of a permanent magnet is to heat it or repeatedly strike it. Why? All right, so remember what a magnet looks like. If you have an iron magnet, you've got all the little arrows pointing in the same way. Now, when it was just a normal piece of iron, they were all pointing in random directions. But when you get a real full-on magnet out of iron, the same thing happens. It just manages to point the same way and then stay that way. You've magnetized it enough that it's able to stay locked in, and if one guy tries to rotate, he's going to wind up being pushed back into the orientation that he was by all his neighbors who were also currently in their location. So what would happen if you heated it? Well, remember, heat means kinetic energy. If you heat it, then you cause the whole thing to shake. This guy shakes, this guy shakes, this guy shakes, this guy shakes. They all start to shake. If they all start to vibrate, then it means that they're vibrating. They're off a little bit. If they're off a little bit, they might start to point in the wrong direction. If they all start to point in the wrong direction simultaneously, they no longer have that peer group effect where they're all holding each other, pointing in the right way. They start to all vibrate a little bit. They start to all get off their track, and boom, it's lost. We lose the magnetic property. So they're going to start to disappear, and they'll start once again pointing in random directions. Now, if only one or two of them manage to turn to a random direction, it might manage to remagnetize itself because it could be pushed back into alignment by its peers. But if they all start to turn because we've heated it up enough, if we heat it to red hot, they're all going to definitely start to change and jostle, and they're going to lose its magnetic properties. Same basic idea behind striking it. If we strike it, we literally jar, we literally shake those atoms, and we might shake those atoms so much, shake those connected molecules, that they're going to wind up starting to spin. They spin a bit, and once again we manage to set off this domino effect where they all sort of spin the wrong way, and we lose the magnetism. We've demagnetized the magnet. All right, I hope that gives you some idea of magnets and what's really going on there, and why it's so incredibly useful and important for all of humanity that we have just, that there is this thing in nature. I mean, I suppose that's true of all the natural forces, right? The electric force, the gravitational force. You and I wouldn't be here if the gravitational force weren't holding us to the Earth and keeping us spun around that nice warm sun. So we've got a lot of cool things happening in physics, and all of it coming together is the reason we can have the things we have. All right, hope you've learned something. Hope you've had a great time. It's been a real pleasure teaching this class, and yeah, best of luck. All right, see you at Educator.com later. Bye.